What you pasted actually connects very deeply to almost all your previous questions. Compiler front-end, recursion, AST trees, React reconciliation, runtime stack, heap algorithms, grammars, tokenization, parser recursion, CPU execution, DSA, even your questions about JSX and Fiber. The issue is that your brain currently mixes together language description versus program execution. Those are different layers. This is the main source of confusion. First, the most important distinction you still blur, you still mix describing valid code with executing code. Second, context free grammar is not runtime. This breakfast to protein or bread is not execution, it is not runtime, it's not CPU behavior, it's not heap memory. It is a mathematical description of valid sentence structure. So it's just a description, it's still in a file. This is the rules that will revolve around converting the raw-text file into a runtime environment. So it's just a description. So it's a representation before transformation. Very similar to HTML grammar, JSON grammar, JavaScript grammar, TypeScript grammar, JSX grammar. So this the grammar that we created in JavaScript, since that has a runtime as well, it is being transported from representation to transformation, which has a runtime. For JavaScript, that's V8 engine. For TypeScript, that's TypeScript transpiler. For HTML, the V8 engine. For JSON, there's also a grammar for that. So those are just grammar. That's not the runtime rate yet. So what CFG really is? A context-free grammar, CFG, is a machine for generating valid strings. Example, protein to bacon or eggs means valid outputs are bacon, eggs. So a valid output for this protein is bacon and eggs. Any other output other than this would not work. So why recursion matters? This breakfast to protein with breakfast is recursive because breakfast contains breakfast. This allows infinite nesting. So the rule itself allow to output a description with its own, it allows to output its own description or its own identifier. Now that allows nesting. So like eggs with bacon, eggs with bacons with eggs, eggs with bacon with eggs with bacons. Now why recursion means more powerful? This is very important. Regular expressions are weaker. Context-free grammars are stronger. Why? Because recursion can generate nested structures, which regular language cannot properly model. Example, function hello, empty parameter inside if parameter x inside is while, parameter while inside is then closing. So you have nested braces for this. It needs recursion. So the reason why a regular language cannot properly model is because this is the nature of code. You have a nested structure, such as in a function. So kind of like a proper data model in database needs a proper modeling of data. It's the same with here. So this is one of your missing links. You often think scanner or parser exist to execute. No. Front-end compiler phases exist to understand structure. execution comes later. So the front-end compiler needs to be able to understand that structure so that it will be able to fetch it into a runtime or into a transition or logic gates, switch, binary that a CPU can understand. So this is really what this compiler is doing. It is making those logic gates language into a more human readable form, such as this function loops. So compiler front end. Now front end compiler, we have source code, then scanner, then tokens, then parser, then AST. Purpose, understand program structure, not execute. So it needs to create a tree because tree is how we transform a source code, a human readable source code, into a tree, into a runtime that a CPU could understand. See, this is how we bridge the front end into a CPU machine instruction. Now runtime is later. After parser, we have AST, then interpreter or compiler, then a runtime behavior. This is where stock heap VM CPU memory allocation begins. So relation to your React questions, React also has description phase versus execution or render phase. JSX, this button, then closing tags is not DOM yet. It is React that create element dot dot dot. Then React create element object to fiber tree. Purpose describe UI structure very similar to AST. So you wanna describe that structure human readable, and then compile that into a machine readable. So we usually use a tree. Even in React, we use a tree to to convert that JSX into a JavaScript. Now deep connection, compiler AST. So you have program, variable declaration, then and function call. Now React fiber tree. In app, you have button and then model. So under that is button and model, and program under that is variable declaration and function call. Both are three representations of structure. 11 reconciliation connection. React reconciliation, old fiber tree versus new fiber tree. Compiler parsing, token stream to AST3. So the reconciliation is like the token stream or scanning of the token, if the token change, to an AST structure. So that's the same with old fiber tree versus new fiber tree in concept. So both systems transform representation. That's the deep commonality. So why grammar generates strings? You ask, why generate random breadpaths? Because grammars are fundamentally formal language generators. They mathematically define all valid sentence. So just like with a grammar in a human language, that produce an infinite meaning because they are just rules that define a valid sentence. It's the same with grammar in the strings. It defines what valid grammar is and what valid sentence could execute by the CPU or machine. So basically, again, you're using a human readable form into a machine instruction, and that's why Dijkstra also said that it might not be good to transform or to use a human language to be able to talk to the computer because it's not near, the more you abstract, the less you really have to use the language near the compiler. So example, grammar defines all valid JavaScript programs, not just one. So we have her pipes. So this bread to toast or muffin means choice, equivalent to or. parenthesis grouping, parenthesis first scrambled or fried string, then egg string means choose one first, scrambled or fried, then append x. So that's what parenthesis means. Postfix operators, another rule for our grammar. These are shorthand. Instead of really to really string or really string really, you can write really string plus. Much simpler. Why recursion is elegant? You ask why recursion is considered purity. Because recursion allows small rules that define infinite structure. Very elegant mathematically. So with think about the recursion is what allows the grammar of the programming language. So just like how grammar allows the infinite meaning of a human language, like expression to expression, plus string expression can generate 1 plus 2, 1 plus 2 plus 3, 1 plus 2 plus 3 plus 4 infinitely. So 17 huge misunderstanding you still have. You often think AST or tree structure is equal physical bytes in memory. No, AST is logical structure. Heap memory is physical runtime storage. These are different abstraction layers. 18 tree structures are not physical RAM shape. RAM is not literally a tree. Tree nodes are objects connected by pointers. So a tree nodes are objects connected by pointers, kind of like a linked list. Example, node A to node B. In memory, you have 0x100, 0, then 0x2AF0, then 0x8810 scattered around heap. The tree is logical, not physically arranged as tree. So this is the pointer. This is what's hard to understand because the tree is not like the physical location in memory. It's logical, in which it's scattered around memory, but they're just connected by pointers. So what makes them tree is the logic structure. Relation to DSA. Your DSA knowledge absolutely applies. Compiler structure. Structures use arrays, linked list, trees, hash map, stocks. Example, compiler part, token string, data structure, array or list. Compiler part AST, data structure tree. Compiler part symbol table, data structure hash map. Compiler part parser execution, data structure stock. Compiler part heap objects, data structure graph. Your TF is correct insight. This insight of yours is extremely advanced. There's a lot of data structure transformation from source file to CPU. Yes, and that's one of the deepest truths in CS. Modern systems are continuous representation transformation. Example, UTF-8 bytes to characters to tokens to AST to bytecode to machine code to CPU signals. How this relates to semantics? Grammar defines syntax, meaning what structure is valid. Semantics defines what behavior means. Example, grammar x plus y is valid syntax. Semantics, what plus actually does. Runtime handles semantics. Example, this is syntactically valid. True plus empty object. Grammars allows it. Semantic or runtime behavior becomes weird. True and then object. So or error depending on language. Front end versus middle end versus back end compiler. Front end we have scanner, parser, AST, type checker. Purpose, understand program. Middle end optimization, back end machine code generation. Relation to your TypeScript questions, type script front end, ES source to AST to type checking, then types arrays to JavaScript emitted. Then types mostly disappear. Runtime never system. Most important missing precision. 25 is still sometimes blur representation versus execution. A parser tree is not running. A React element is not DOM. A token is not runtime value. An AST is not a machine instruction. These are intermediate representations. That distinction is critical for advanced CS understanding. Final unifying idea. Everything you are studying, compilers, React, Fiber, DDIA, database, networking, interpreters, operating system, all revolve around transforming representations between abstraction layers.